Hello everyone. Right now I'm going to talk about matrix equation which is Ax equals to B. Uh, Namely, I want to explain what is linear combination and we will solve one question from that topic. A is our any matrix. It can be matrix by any size. 2 by 3, 3 by 2, 4 by 4, 5 by 5, anything. X is our vector matrix and B is our linear combination. It also can be a matrix by one column. So let's try the definition. If matrix A, the size by n is a matrix with the columns A1, A2, and AN, and X is in R, which is real numbers in power n, then the product uh, A and X denoted by AX is the linear combination. Of the columns A, um, using the corresponding entries. In other words, entries is elements in X as weights. A11, A21, A and 1, X, X1, X2, Xn. So let's write our linear combination formula. AX, no. Let's write with size. Let's mention the size as well. A um, size n by n times x n by 1. By the way, in previous video when I was talking about multiplication of matrices, it's very important to um, be into account how we can multiply them. There is special requirements. If the amount of columns in matrix A is the same as the amount of rows in vector X, so we can multiply them. Otherwise, in other way, no. So A1, A2, AN times X1, X2, Xn. So it's going to be X1, A1 plus X2, A2 plus Xn, AN. Let's go back. Uh, our definition. Yeah. So let's solve some question. Determine whether B is the linear combination of the columns of the matrix A. So we have such matrix decised by 3 by 3, 1, minus 2, 0, 1, 0, 1, 3, minus 2, 1. What about B? B is a linear combination, but we have to determine it. If you don't know what to do here, just remember the equation AX equals to B. So we have everything. We have B. So what do we need here? We have to find X. So let's write uh, our matrices in terms of this equation. So 1 minus 2, 0, uh, 0, I1, 0, 1, 3 minus 2, 1 times x1, x2, and x3. Since we have the size of a 3 by 3, this 3 is n, so that's why the last entry of vector x is also 3, equals to 2, 3, 8. Let's write it in augmented matrix form. Augmented matrix C, uh, which is there is a matrix A. We also can call this matrix as non-homogeneous matrix. All right, so let's do some row operations to get more zeros and get our values for our variables. R2 is R2 plus 2 R1. So it's going to be 1, 1, 3, 2. Minus 2 plus 2, 0, 1 plus 2, 2, minus 2 plus 6, 4, 3 plus 4, 7, 0, 1, 1, 8. Uh, R3 is 2, R3 minus R2 because I want to eliminate this one. 1, 1, 3, 2, 0, 2, 4, 7, 0, 0. 2 minus 4 is minus 2, and 16 minus 7 is 9. So we got pivot position in this position, in this position, and in this position. X1, X2, X3 are basics. There are two types of how we can define our variables. The first type is basics, and the second type is variable. For example, uh, when you have such a case when um, there is only, let's say, uh, for example, you have only two positions, two pivot positions, not three pivot positions, only two. So we can call x1, x2 basics, but what about x3? It's just free variable. If there is no pivot position, it means position is 0. So let's find our variables. Minus 2 x3 equals to 9 from this row. So x3 is gonna be minus 9 over 2. Let's revise the second row. 2x2 plus 4x3 equals to 7. 2x2 plus 4 times minus 9 over 2 equals to 7. It's going to be divided by 2. So it's going to be 2x2 minus 18 equals to 7. 2x2 equals to 25, and x2 is 25 over 2. What about the first row? x1 plus x2 plus 3x3 equals to 2. Uh, x1 plus 25 over 2 plus 3 times minus 9 over 2 equals to 2. X1 plus 25 over 2 minus 27 over 2 equals to 2. From here, it means like 25 minus 27 is minus 2 divided by 2 is minus 1. Minus 1 is going to the right side, so it's going to be plus 1. Uh, 2 plus 1 is 3, so x1 is 3. So we got our values for our variables, so let's write it in vector equation form. 3, which is x1, the first column of matrix, what was that? 1 minus 2, 0, plus x2 is going to be 25 over 2. What was that? I guess 101. Yeah, 101 plus or minus. Yeah, minus 9 over 2. 3 minus 2, 1. 3 minus 2, 1 equals 2, 2, 3, 8. Yeah. But in alternative way, uh, it couldn't be our linear combination only in one or in different cases if one or two or even three of our variables could be zeros. So since we got our numbers, real numbers, so we can say that B is linear combination. Thank you for attention.